Alright, in this video we're going to talk about geometric sequences. Okay, so the first thing we need to see is what is the definition of a geometric sequence. You'll want to write this on your graphic organizer that I have given you. Okay, a geometric sequence, remember, is a sequence where you find the next term in the sequence by multiplying by a constant, or in other words, the same number. So if you have a geometric sequence, then if a sub 1 equals a, and r then is the common ratio. In other words, this is what you multiply by. Alright, the sequence then looks like this. So a geometric sequence actually looks like this. AR to the second power, AR to the third power, AR to the fourth power. Okay, so let's see what that really looks like then in a problem. Alright, so let's take example 1 here. It says we've got the sequence 3, 6, 12, 24, 48. We want to know what a sub 1 is, what r is, if it's geometric. So let's see first if it's geometric. So to decide that, we're going to very easily find the ratio. So basically, you're going to list all of your sequence terms, and then we're going to find the ratio between consecutive terms, one after another. So what I'm going to do then, I'm going to find the ratio of the first two terms is this term divided by this one. Okay, so that would be 6 over 3. So this one then would be 12 divided by 6. This one is 24 divided by 12. And this one's 48 divided by 24. Okay, so now what we want to do is we want to see, are those things the same? Okay, so basically what we're going to be doing then is dividing all of those. So we're going to divide 6 divided by 3. And it's going to equal 2. 12 divided by 6 is going to equal 2. 24 divided by 12 is going to equal 2. And 48 divided by 24 is also going to equal 2. So our common ratio then, or our r for these, would be 2. Okay? So r equals 2. And then remember that our a sub 1 was our first term, so a sub 1 was 3. So those are the two numbers we were trying to find, and we found those. Okay, let's take a look at another example. So we have this sequence in example 2, 3, 6, 9, 12, 15. All right, so let's do the same thing we did for example 1. So we're going to write our sequence terms down, and then we're going to find the ratio. 6 divided by 3, okay? 9 divided by 6, 12 divided by 9, 15 divided by 12. All right, so the first one I'm going to go ahead and do, and I know it's 2, right? So we know that none of the rest of these are 2. So then this one's not 2, this one's not 2, and this one's not 2. Alright, so then what I'm going to ask is this a geometric sequence? It's not, because the ratios were all different. They were not all 2. So this one is not geometric. Okay? It's not geometric. Alright, now let's look at example 3. Alright, example 3 has numbers raised to a power. And remember in these terms that this number represents the base. This number represents the exponent. Okay? So we'll then remember that when we look at these, I have 3 to the 5th power, 3 to the 10th, 3 to the 15th, and that's 3 to the 20th. Okay, so I'm going to write those terms down just like before. And I'm trying to find a sub r for these, so I do exactly the same thing. I'm going to make a common ratio. So I take this term divided by the first one, this term divided by this one, and this term divided by this one. Okay, now, what we have to remember are our rules when we have exponents here. All right, so this is an important concept to write down. When the base is the same, so because all of these are 3, we can use this rule. To divide, you're simply going to subtract your exponents and put the answer where the large exponent is. All right, so if we look across at all 3 of these, the large exponent's in the top or in the numerator. So when we divide, then we have, this would actually be then 3 to the 10 minus 5. And all we do is subtract those exponents and get 3 to the 5th power. This one would be 3 to the 15 minus 10, which is also 3 to the 5th. And then this one is 3 to the 20 minus 15, which is also 3 to the 5th. So this one is geometric. Now, so your a sub 1 is your first term, which is 3 to the 5th power. All right. Your r, or your common ratio, is what we got when we divided, which happened to be 3 to the 5th power as well. Okay, now it won't always happen that they're the same, but it did happen that way in this term. All right, so let's go back again. And we have the original sequence. We found our ratio. And then we identify those pieces right here. Now, what you need to make sure that you've done is to put all the information that you needed on your graphic organizer, beginning with your original term, which was geometric sequence, and then on your graphic organizer, it asks if there's a formula. Well, not yet, but there's getting ready to be one in the next video. So we'll watch the next video to finish up your graphic organizer.